Okay, so for this video, we're going to go ahead and cover geometric constraints and different uses that you can use for them. Now, what is a geometric constraint? Pretty much, it's a set of rules that you apply to the geometry of your sketch in order to make it behave in a certain way. You can really think of it a lot like your dimensions from another video, whereas if you put a dimension on a line, you've now told that line, you've given it a rule of how it needs to behave. So if I make this line out here, and then I dimension it, press D, it now must be 50 millimeters no matter what. So no matter where I move it, it has to be 50 millimeters. It's locked in, it's a rule. Whereas geometric constraints give it rules based off of, as the namesake says, geometry. Okay? Where that really becomes useful is that if you make a sketch, you finish it all the way, you do it everything by rapid dimensioning. If you run into an issue where you suddenly have to make your model twice as large, you have to go into every single dimension that you've created and multiply it by 2. And now it's not hard, but it's very tedious, and it can become a very daunting task whenever you make much more complicated shapes. Geometric constraints require a little more thought, and I say a little more, but once you get used to it, it's almost second nature um, in order to use them properly. But they allow for a lot more flexibility because of the nature, since it's by the geometry. So usually you'll end up force dimensioning one side, and then the rest of the sketch will be constrained via geometry. So if you have to double it, you just double that one actual number that you've given the sketch, and the rest of the shape will follow suit. Okay? Now, of course, if you go into your dimensioning and then you can be clever with your rapid dimensioning too. I don't want to dissuade you against doing that, but everyone has their own ways that they go about doing it, and geometric constraints is something that I think is really useful for everybody. So, what we're going to do is we're just going to cover it. How to get there, of course, you go to More, and you go to geometric constraints. This is after you've already created a sketch. So you notice I have a sketch made, finish sketch. I have to open it up in order to get those constraints. Also note that I've turned off continuous auto dimensioning. Get in the habit of making that the first thing that you do. For geometric constraints, you can either go into this More menu and then go to geometric constraints every time, or you can press C, as in cat, in order to Sorry, I had to make a quick cut there, but as I was saying, you can press C in order to bypass all of that, and you'll just open it up much, much faster. Okay? Now we'll go through these, try to go through them one at a time. I'll just be making sketches here. It doesn't matter what units you're in, I'm really just playing around. Okay? So I'm just going to make 2 lines. It doesn't matter. C again, coincident, and what this means is that it will connect these 2 lines. So I'll select that one, and then I'll select this one. If you guys noticed, there was a little menu here that I had to follow. So I selected my object to constrain, which was this line. After I'd selected it, there was a green check mark, and then I select the next part. I'll go ahead and do that again. So I'm going to press Control Z in order to undo that. Press C again. Now I will click this one. You notice how there is a green check mark there now. My next object, I'll select this one, and it will automatically jump to it. Now this is just because I clicked it at a weird spot, so let me just click it quickly. There you go. Don't worry too much about that menu. It was just asking which point I wanted it at. Was it over here, or was it over there? Okay, and that's coincident. So that's really useful if you're making a shape, but you didn't fully close it for whatever reason. So that's not completely done. So you could extend the lines and do that to connect the shape and close it off, or you press C, click this line, then you click this line, and bam, now it's closed. Okay, let's go ahead and move on to the next one, and that next one is going to be point on curve. Point on curve is really useful for like circular things. You can also use it for like linear slopes, stuff like that, but I think what you'll find the most benefit out of is manipulating circles. Now, we have a circle that, of course, it has no straight lines. So we can't use collinear or stuff like that. You'll see what I mean as soon as we cover that later. Now we go to here, and we'll do point on curve, and we'll use our X and our Y axis. So I'm going to select my object to constrain. It's very important that you make sure that the little orange dot is right there in the center. And then object to constrain, I select my Y axis, and boom, now it's locked into my Y axis. I'm now going to try to do it for the X, but if you notice, I can't go back and change it, right? Because it's locked in to be here. I can't force it to come over here as well. So what I'm going to do is I'm going to undo that, and press C again. Click this center point and click this down there. Okay, so you'll use that for whenever you're making sketches. Usually what we like to do in the class is we'll make a circle, we'll cut a line through the center, or actually we'll make it a smaller, we'll put 2 circles, and then we'll cut a line just like that. Well, let me go ahead and make that touch, and then you want to put this little one over there. You'll use point on curve. Select from list, that line. And now we've moved it to this one. We can still manipulate this and touch it around however we want, but you get the idea. It's for manipulating it like that. Okay. Next is tangent. Again, we'll be dealing with circles and edges. For this case, it's just easy if I just show that. Now what it will do is it'll move this circle to be tangent to this line. That's not a good example because that one line is just at 90 degrees, so let's put it over here. So it will force the circle to come over here. Tangent, bam, bam. Okay. Next we're going to be covering parallel, and of course parallel, pretty obvious. And then let's make those completely opposite. And that's parallel. You notice it'll say that as I hover over it. Okay, those lines are now parallel. And of course, you can't have parallel without having perpendicular. Now the reason these aren't connected is because it just forces this line wherever it is. I never gave a rule to say that this line has to touch this line. If I want, because I can still manipulate it, I can go ahead and just put it closer for visualization's sake. Okay, but it won't behave that way on its own unless you put in a rule. Moving it around like this does not constitute a rule though, so keep that in mind. Okay, this is just me manipulating my sketch. So if I can move it like this, there isn't a rule. Think of it like that. All right, next we're going to do horizontal and vertical. Those are also very simple ones. Horizontal, vertical. It determines its horizontal and vertical based off of this right here, which will be the axis of that specific sketch. So if you have a sketch at an angle on a model of a 3D face, something we'll cover later, it will use based off of that reference point. Okay? Midpoint, pretty much the namesake. Yeah, so midpoint, pretty much the namesake, moves the objects to the middle. So this line is in the middle of this one. If I wanted to go in the other way, this line is now in the middle of that. Pretty straightforward. Collinear is one that's a little more interesting. So if I have this line and this line, collinear will make these 2 lines act on the same angle, pretty much. So if I select this one, and I move that there. Oh, I was still on midpoint. Collinear, this one, over here. They're now both horizontal. If I wanted it to go the other way, I need to make sure that doesn't have a horizontal constraint. Like that. Now some of you will notice that I deleted a horizontal constraint, but I never told this line to be horizontal. That's something you need to watch out for. NX loves to force constraints on you. So that horizontal constraint, you can see it forced itself. You just right click X and it goes away. Okay. The rest of these are pretty simple, so I'll cover those all at once. So it's concentric, equal length, and equal radius. So let me just make some lines, these 2 lines, and then make a series of circles. Okay, so concentric, it just means that one circle has to be inside of the other. So if I make this line, click this one, that one goes inside of there. That's all that means. Equal length, namesake, lines are now equal. Equal radius, namesake, these circles are now equal. That wasn't too good of an example because these circles weren't drastically different. So let me go ahead and delete that one and make a much larger circle. Move that over in frame. Constraint equal radius this one to this one. Okay, now they're both the same. What I want to finish up with is this shape. So this is something that I provided all of you through Blackboard, and what you'll do is pretty much try to do these exact steps that I'm going to do so that way you can play around with them yourself. So I'm going to go ahead, open up the sketch, and the first thing I want to do is I want to make these lines all collinear. Okay, so I just select those three, object to constrain, they are now collinear. Next thing I want to do is make these lines equal radius. So I'll select this one, or equal length, I'm sorry. And then now they're all equal length. What I also want to do now is force these to behave in the same length. So I'm going to just make all of these as short as this pair right here. And that's going to cause us, okay, so went a step further than what I wanted, so I will do that last. What I want to do instead is I want to make this one vertical. Okay, so you see this one is now horizontal as this one. Another way you can do that is you can make this line parallel to this one, and the other lines have to follow since they're all collinear. Next, if you want to fix these, all you really have to do is you pull it up. Okay, so you can drag it and pull it back up here so that way you can actually manipulate it. And now I'll make them equal. So let's make them equal to that one since that one came out real nice. Okay, now they're all set. I can also make these lines equal to each other. And that changes the bottom one. Okay, and that's pretty much messing with it yourself. Let's see if we can't fully constrain this. So you can see what needs more constraints by dragging it around. So you see this length is not defined. So what I can do is I'll just go ahead and fully define this one. So I'll put 140 here. Alright, and then I'll fully define this one. So what I mean by fully define or hard define is just force it to behave that way no matter what. So you see we're still missing 5 more constraints. What we can do is we can make this collinear. Okay, so now that means that this line is now collinear to the x-axis. Now we'll also define how far away we want it from the x-axis, so I'll click this point, and then I'll click the origin, and now I have this distance that I can manipulate. And let's make that 25. Okay, we still have 3 more constraints that we can move, so let's grab a line, see what changes. So you see this one, there's no, well actually this has another line in there for some reason, so let me see what's up here. This has another line. Yeah. So let me just make a new line that touches that, and then we'll put this distance now. 25. Okay. 2 dimensions to go. And if I had to guess, yeah, it's in here. We never forced it to be anything. So if I make a height from this line to here, and then we'll make that one also 25. One last constraint, and if I have to guess, it's these. Yeah, and then it's forcing this one. So we make that 20. Okay, now notice how we do have actual dimensions and also geometric constraints. So you'll use a combination of both of those as you're sketching throughout the class. But because of how this is set up, I can now make changes very, very quickly. So 150, and it's adjusted all the rest of this. Now notice everything that's hard to find with numbers are not changed. Anything that can be manipulated does change. Okay, so what that really means is the distance between here, since it's not forced to be any specific number. If I did force it to be something, I would start getting an over-constrained message. Yeah, and I'll go ahead and cover that in a different video. But that's pretty much the overview of constraints. There are other example problems that you guys can cover in the lecture posted on Blackboard. Go ahead, give those a shot. Make sure that you're familiar with these. I know they're different from 360 slightly, but it should be okay. All right, just go around and play with it. Of course, leave questions in the comments or emails if you have any.